Welcome back to Math with Miss Reimer. Today we're looking at section 5C, which is elimination. Elimination is a method for solving systems of equations by adding the equations together and then eliminating a variable. First, we need to make sure that our equations are lined up. The x's need to go together, the y's, the constants. Think just like place value when you're adding numbers, the ones, the tens, the hundreds. Step 2, we're looking for equal and opposite coefficients. You're going to hear that over and over again. We're looking for equal and opposite coefficients. Remember, coefficients are the numbers that are next to the variable. For instance, 4 and 4y. We will multiply one of the equations by -1 if necessary to get opposites. So if we have numbers that are the same, like 3x and 3x, if we need opposites, we can multiply one of them by -1. Step 3, we will add the equations to eliminate the variable with the opposite and equal coefficients. We'll solve the equation for the remaining variable, and we'll substitute your answer into the original equation and solve for the other variable. So what this actually looks like in a problem would be here in example 1. Notice that right now I have equal and opposite coefficients in my x's. This has a coefficient of 1. This one would be -1. Remember our imaginary ones here. So we have equal and opposites, which is already what I need. So when I have equal and opposites, I'm going to take the two equations and I'm going to add them together. I already have my x's, y's, and my constants lined up. So 1x plus -1x cancels. You're always looking for one of your equations to add to 0 or to cancel out. 4y plus 1y is 5y, and then 13 minus 3 is 10. This is what should happen. One of your variables cancels out. Now solve for y. Divide both sides by 5, and you will end up with y equals 2. Now, just like when we did substitution, when y equals 2, we have to go back and find x, so I can plug in y equals 2 to either one of my original equations to solve for x. So, for instance, if I use the first equation, I'll do x plus 4 times 2 equals 13. That 2 going in for y. I'll end up with x plus 8 equals 13. Subtract 8 from both sides, and we will end up with x equals 5. Now I've found both of the pieces of my equation, and so my answer is 5, 2. That's the solution to these equations. That means if you were to graph both of these, they would cross at 5, 2, and when you plug in 5 for x and 2 for y, that is the only set of numbers that will solve both of these equations. Same thing in number 2. We're looking for equal and opposite coefficients because I already have my equations lined up. My equal and opposites here will be my 3's. So I'm going to add these equations together. My 3's cancel. -10y minus 9y gives me -1y. And 14 minus 15, or plus -15, gives me -1, which is the same as y equals 1. Take that y equals 1, plug it back into one of my original equations. So I'll take 3x times 10 minus 1 equals 14. I'll add 10 to both sides, get 3x equals 24, or x equals 8. Now that I have both pieces, my solution here is 8, 1. There we go. I can add my two equations together. 4x plus 2x is 6x. My y's cancel. 6 plus -18 is -12. Divide both sides by 6, and we get x equals -2. Now we have half my answer. I need to go back and find the other half. So take your -2, plug it in for x, and then solve your equation. So you'll have -8 plus 2y equals 6. Add 8 to each side. We'll get 2y equals 14, or y equals 7. Once I have my second piece of my equation, I can put my ordered pair together, and I get -2, 7. In number 4, you'll notice our equation is in a different order, but all of my like terms are still lined up. My equal signs are together, the y's, the x's, and the constants. Notice I also have my equal and opposites in my y's, which is fine. Now in this case, when I go to cancel these, I need them to cancel to 0. I'm actually going to write that 0 because there has to be something on this side of the equal sign. 3x minus x is 2x. And then 4 plus 2 is 6. Now, that 0 is holding the place here, but I'm still going to try and get my variable by itself. So I'll subtract 6 from both sides, divide both sides by 2, and you get -3 equals x. Now go back and solve for y. So plug -3 in for one of your equations. I'll just use the first one. I've got 3 times negative 3 plus 4. 3 times negative 3 is negative 9 plus 4 is negative 5. So I have the two pieces I need to write my ordered pair. I've got negative 3 As we come to example 5, we're going to notice that we have equal coefficients here, but we don't have opposites. When we don't have opposites, we can multiply the entire equation by negative 1. So think of it as I'm going to multiply this whole equation by negative 1. In essence, when I'm multiplying by negative 1, though, I'm going to flip the sign of everything that's already there to take care of my negative 1. So once I flip the sign of everything, now I've got equal and opposites, and now I can go ahead and add through. My 4x and my negative 4x will cancel. 7 and 9 is 16y, and 5 and 11 is 16. Divide both sides by 16, I get y equals 1. Now plug that back into one of my original equations. So 4x plus 9 times 1 equals 5. I'll subtract 9 from both sides. Get 4x equals negative 4, or x equals negative 1. Now that I have both my pieces, I can write my ordered pair at negative 1, 1. In number 6, again, we're going to notice that we have equal coefficients but not opposites. So I can multiply the entire equation through by negative 1. You can do this to either the top or the bottom. I'm going to go ahead and do it to the bottom. So that's going to flip the sign of everything in my original equation. And then I can add through to my equations. 10x minus 2x is 8x. My y's cancel, and 16 plus 6 is 24. And I end up with x equaling 3. Take that x equals 3 and plug it into one of your original equations. I have a habit of doing the top one, but it doesn't matter which equation you use. They'll both give you the same answer by the time you're done solving. Here as we go, we'll end up with negative 12, and then y equals positive 4. I've got my two pieces, so this comes out to 3, 4 as my solution. On example 7, one of the first things you should notice is that our equations are not completely lined up. The x's, y's, and constants are, but the equal signs are in two different places. You can't add through until your equal signs are in the same spot. So to get them in the same place, I'm going to subtract 3y from both sides of my equation, which will leave this as x minus 3y equals 11 and 2x minus 3y equals 16. Now I've got everything lined up, including my equal signs. I still need to get opposite coefficients. I've got equals and negative 3, but I still need opposites. So I'm going to multiply through by negative 1, which will flip the sign for everything in that second equation. And when I go ahead and add through, x minus 2x gives me a negative 1x. My 3y's cancel, and I have 11 minus 16, which gives me negative 5, or x equals positive 5. I can take that 5 and plug it into either of my original equations. I'm going to go ahead and use the top one. Sure, why not? I can plug it into this equation or either of these two, and I will still get the same answer by the time that I am done. Subtract my 5 over. I'll end up with 6, or y equals negative 2. So my answer is 5, negative 2, the ordered pair. Opposites, that we actually have two sets of equals. So when we multiply 1 through by negative 1, we are actually going to cancel both of our sets of variables. Remember, these are actually canceling to 0, so that's what I can leave as my placeholder. Negative 10 plus 13 comes out to positive 3, and we know that 0 does not equal 3. So since this is a false statement, you're looking at no solution because these are parallel lines. No solution because these will actually end up being parallel, which means they never cross. In number 9, you'll also know that we have two sets of equal and opposites. So when we add through, again, both of our sets of variables will cancel. So I leave the 0 to hold the place. But notice that negative 10 and 10 will also cancel. 0 equals 0 is a true statement. So that would be infinite solutions because these are the same This is Stanley and Miss Reimer saying, see you next time.